Alright, so this is Chapter 4, Section 1, Part 2. So at the end of the class period, you guys need to upload Part 1 and Part 2 notes. So Part 1 we did on Friday, so you should have those completed already. And Part 2, you just have to watch the video, and we're going to do them together. So just a little review from Part 1. This is going to help us graph our functions. So again, just a review of the end behavior. When our degree is odd, that means our end behavior is going to be in different directions. And if it's positive, it always ends going up. And since it's odd, different directions. So it starts going down, ends going up. If it's odd and negative, it's going to end going down. And since it's odd, it starts going up. If our degree is even, that means they go in the same direction. So positive would be up and up. And then even and negative would be down and down. To graph a polynomial function, first thing we need to do is plot points. So we're going to plug in numbers for x and get numbers for y to determine the shape of the graph. And then we connect the points with a smooth, continuous curve and use what we know about the end behaviors to sketch the graph. So again, we're going to have to decide what our end behaviors are, and that's going to help us graph the ending parts. So we have two examples here for example number 4. A, so this A just goes with this A. So our function is f of x is equal to negative x cubed plus x squared plus 3x minus 3. So looking at our first term here, we know our end behaviors. Since it's negative, it's going to end going down, and since it's odd, it starts going up. So again, that degree, that 3 there, tells us that it's odd. That's what we need to look at to see if it's odd or even. And then the coefficient out front tells us negative or positive. So here it gives us a little box. We're going to plug in all of these numbers for x and get values for y. So here it just says f of x. Remember, f of x is a fancy way of saying y. So first we're going to plug in negative 2. So we have negative. Remember that negative is on the outside. Negative 2 cubed plus negative 2 squared plus 3 times negative 2 minus 3. So negative 2 cubed would be negative 8, and negative 8 times a negative would become positive 8. Negative 2 squared, so this is plus 4. 3 times negative 2, negative 6, minus 3. 8 plus 4 is 12, minus 6 minus 3, so 12 minus 6 is 6, and 6 minus 3 is 3. So when we plug in 2, we get 3. So we go to our coordinate point. This is negative 2, 3. So we go to the left 2 and up 3. Put a point there. Next, we are going to plug in negative 1. So I'm going to do that on the side over here. So we have negative 1 cubed plus negative 1 squared plus 3 times negative 1 minus 3. Negative 1 cubed would be negative 1 times a negative would become positive 1. Negative 1 squared is positive 1. 3 times negative 1 is negative 3 minus 3. So this is 2 minus 6, which is negative 4. So when we plug in negative 1, we get negative 4. That means our second point is negative 1, negative 4. So we go to our graph, go to the left 1, and down 4. Next, we plug in 0. So we have 0 cubed, negative 0 cubed, plus 0 squared, plus 3 times 0, minus 3. This is going to be negative 3. So when we plug in 0, we get negative 3. Next, we can plug in positive 1. So we have negative 1 cubed plus 1 squared plus 3 times 1, which is just 3, minus 3. So this is -1, +1, and then the 3's cancel out, the 1's cancel out, so this is just 0. So when we plug in 1, we get 0, so 1, 0 is our point. So go to the right one, stay on 0. And then next we plug in 2. So we have -2 squared, 2 cubed, plus 2 squared, plus 3 times 2, minus 3. So -2 cubed would be -8, plus 4, plus 6, minus 3. This is -4, plus 3, so -1. So we go to the right 2 and down 1. Now we said our end behavior is starts going up and ends going down. So this graph is going to start going up, and then we just connect our dots, and then it ends going down. So our graph looks about like that. So this is not a perfect representation of our graph, but it's a good enough estimate. So always, we got to plug in points, and we got to check for our end behaviors. All right, let's do B. So here our function is x to the 4th power minus x cubed minus 4x squared plus 4. So we're going to look at this x to the 4th power. We see that it's positive, so it's going to end going up, and it's even, so they're going to go in the same direction. So it's going to start going up and end going up. So it's going to go up and up. First thing we're going to do is plug in -2. So -2 to the 4th power minus -2 cubed minus 4 times -2 squared plus 4. Anytime that you have an even number, so anytime you have an even exponent, your number in here is going to turn positive. So if we had -2 squared, this is -2 times -2, a negative times a negative would be a positive. So anytime your exponent is even, the number becomes positive. So -2 to the 4th power would be 16. Anytime you have an odd exponent, your number stays negative. So -2 cubed would be -8, but then we have this negative out front, which makes it a +8. -2 squared is +4. +4 times -4 is -16. Plus 4. So +16 and -16 will cancel each other out, so we just have 8 plus 4, which is 12. So when we plug in -2, we get 12. So we go to the left 2 and up 12. So it would be there. Our graph only goes to 10, but we can just go a little bit off the chart. Next, we're going to plug in -1. So we have -1 to the 4th power minus -1 cubed minus 4 times -1 squared plus 4. So anytime this is an even exponent, our number changes signs. So this would become +1. When it's an odd exponent, it stays as a negative, but we still have that negative outside, so -1 times negative would be +1. This becomes a +1 since it's squared, times -4 would be -4 plus 4. So the 4's cancel out, so this is just 2. So when we plug in -1, we get 2. Next, we're going to plug in 0. So we have 0 to the 4th power minus 0 cubed minus 4 times 0 squared plus 4. This is just 0, 0, and 0, so our answer is 4. I forgot to plug in -1 too, so we go to the left 1 and up 2. 0, 4, we stay at 0, go up 4. Next, we need to plug in 1. So we have 1 to the 4th power minus 1 cubed minus 4 times 1 squared plus 4. So this is 1 minus 1 minus 4 plus 4. So this is a positive 1 and a negative 1. They cancel. Negative 4, positive 4, they cancel. So this is just 0. So when we plug in 1, we get 0. Next, we plug in 2. So 2 to the 4th power minus 2 cubed minus 4 times 2 squared plus 4. 2 to the 4th power is 16. 2 cubed is 8. 2 squared is 4 times negative 4, negative 16 plus 4. So 16 and negative 16 cancel. Negative 8 plus 4 would be negative 4. So we plug in negative 2. We go down 4. So we put a point right there. So we said our end behavior is up and up, right? Yep, up and up. So we see here that it's going to end going up. Then we need to connect our dots here with a smooth continuous line. We don't end going down, so we can't put our arrow there. We know we're gonna have to end going back up, so we can just put our arrow there. So again, this is a rough estimate of what our graph is gonna look like. We don't know that it goes back through at this point exactly, but it does go back around and goes back up. So this is just a good estimate of what our graph is gonna be. So we need to have these arrows going up, and then we need to plug in our points to see what it looks like. Also, a key note here is that we connect the points with a smooth curve and then just check the end behavior. So we can't have our graph connecting the dots like this. It has to be with a smooth curve. For example 5, we are sketching a graph given the following characteristics, and we need to use the graph to describe the degree and leading coefficient of f. So the first 2 points here tell us when f is increasing and decreasing. The second 2 points tell us when it is above or below the axis. So here when f of x, remember f of x is just a fancy way of saying y. When f of x is greater than 0, we know it's going to be above our x-axis. So it's going to be positive y's up here. If it is less than 0, then we know it's going to be below. So I'll highlight up here. This is above when it's positive. I'll draw a little graph so we know it's above. And then this one is below our x-axis when it's negative. So I'm going to draw my graph down here. Oops. And put my labels on it. So I know I'm talking about when x is from 0 to 4. And then we have negative 2 to 5. So I'm going to go to the left. I'll go 3 because this would be negative 3. And then I need to go to the right at least 5. So I'm just using the numbers that we were given here just to label it. If I wanted to put 10 dash marks on each side, I could. But I'm just going to do what I need. So this one's 5. So f is increasing, so our function, that's what this stands for, function, is increasing when x is less than 0 and greater than 4. So our function is increasing when x is less than 0, so it's increasing until it gets to 0 here. And then it's also increasing from when x is 4 to greater than 4. So from this point at 4 to greater than 4. Now I'm putting it above just so we can see, because I don't know exactly where our graph is going to be. So I'm just making a note that from less than 0 and greater than 4, our graph is going to be increasing. Now f is decreasing from 0 to 4. So from this point to here, it's going to be going down. Now f of x is greater than 0, so it's going to be above our x-axis when x is from -2, so this point here, to 3, so this point here. So let me change the color here so we can see it. So we're looking from -2 to 3, we are above the axis. So we know we're going up from here to here, so we're just looking from -2 to 3, so we're going up until we reach this point, and then we're going down until we get to 3. So I'm only looking at this part here to show us where we're increasing and decreasing. So we're increasing and above the x-axis from -2 to 0, and then I'm decreasing from 0 to 3. Next, we're below the x-axis when x is less than 2. So this part of our graph here, we're increasing, but we're below the x-axis, so I'm going to put that down here. And then from 3 to 5, we are below the x-axis. So from 3 to 4, I know I'm decreasing because this little part, I'm still going downhill. But then at 4, I go back increasing. But I am still below the x-axis until I get to 5. So I'm below the x-axis until I get here. So I need to stop at this point at 4, go increasing, but I'm still below the x-axis. So our graph is going to look like this. So in doing these, I always like to look at the first 2 points that it gives us when it's increasing and decreasing, and just draw that above our graph so we get an idea. And then for the second 2 points, that's when we can actually start putting points on our graph, but we still need to look at when it's increasing and decreasing here. So this part up top isn't part of our graph, we just ignore this, but that's what helps us determine where we're increasing and decreasing. So our graph is this part here, this is our function. So we just ignore everything here, we can erase it, but that's just what tells me where I'm increasing and decreasing at what points. And then I can look at part 2 here, these 2 points, and actually plot points on our graph. Next thing we need to do is use the graph to describe the degree and the leading coefficient. So we see that our graph starts going down and ends going up. We look at our arrows here, so it starts going down, ends going up. If it ends going up, that means our leading coefficient is positive. And since it's going in opposite directions, that means it is odd. So here, our leading coefficient is going to be a positive number because it ends going up, and it's odd since it starts going down. They're going in opposite directions. Okay, so since there was only one example in the notes, I wanted to do one from the homework too. So you guys don't have to include this in the notes that you turn in, but this is one of the homework problems. So if you're still want extra practice, I would just suggest watching the video so we can get a little bit more practice doing these graphing ones. So we have our graph here. Looking at our first point, f is increasing when x is less than -1 and greater than 1. And then our other numbers here go to 1.5, so I'm just going to go to 2 on both sides of my graph here. And notice how I only put numbers on the x-axis because all we're talking about here are our x's, really. We're just looking at our x's. Those are the values that are important here. So f is increasing when x is less than -1. So anything less than -1, our graph is going to be increasing. So until it gets to -1, we're going up here. and x is greater than 1, it's also increasing. So we're also going up here. Oops, -1 or +1. So this starts here, going increasing. So everything less than -1, -1 is this point, we're increasing. Everything greater than 1, we're increasing also. Our graph is decreasing when x is in between -1 and 1. So here we're decreasing, we're going down. So a general direction of our graph, we're going up, then down, then up. Now we need to read our second point and put our points actually on the x-axis here to get a better idea. So y is greater than 0, meaning it is above the x-axis from -1.5 to 0. So from -1.5, which is about here, to 0, here, we're above the x-axis. So we want to follow this shape, but above the x-axis. We're going to put that here. So we go from increasing here to decreasing, because that's what it told us here. So from 1 to 0, we change here. So we're increasing and then decreasing. Next, we're also above the x-axis when x is greater than 1.5. So 1.5 is here. We're above the x-axis and we're increasing. So we're going up here. Now, x is less than 0, so this is below the x-axis. When x is less than 1.5, -1.5, so we're below when x is less than -1.5. We need to follow this direction, so we keep that same shape there. And then it is also below from 0 to 1.5. From here to here, we need to go decreasing until 1 and then increasing. So we're decreasing until 1, then we change to increasing. So this is our graph. We can ignore, I don't want to erase it because I want you guys to be able to see it, but we ignore everything up here. That just is a guideline for us. What's important is our graph here. This is our function. This is our f, our function. So now we need to, let's see what the directions say. Describe the degree and the leading coefficient of the function. So our leading coefficient, since it ends going up, we know it is positive. And it starts going down, so it goes in opposite directions, which means it's odd. So this is just an example from the homework, just to give you guys more practice. Again, you don't have to include this one in the notes, but it's here if you guys just wanted to see another example. So your homework is everything on this page. You guys only had one page, but you have to do all the problems. Don't forget, you need to turn in the notes. Make sure it has part 1 and part 2 included in it. So you have to turn in 4.1 completed notes, everything.